1. Sound waves. The invisible conversations. Sound waves are everywhere, yet we rarely pause to consider their magic. They are vibrations traveling through a medium, air, water, or solid objects, carrying energy without moving the matter itself. Imagine whispering to a friend across a room. Your vocal cords vibrate, pushing air molecules. Those molecules nudge others in a chain, transmitting the signal until it reaches your friend's ear. Inside, tiny hair cells in the cochlea convert mechanical vibrations into electrical signals that the brain interprets as sound. Historically, humans have been fascinated by sound. Ancient Greeks, like Pythagoras, studied vibrating strings on musical instruments to understand pitch and harmony. By the 19th century, scientists like Helmholtz analyzed sound mathematically, and tuning forks became tools for exploring wave behavior. Even now, acoustic engineers design concert halls, theaters, and recording studios to manipulate sound, controlling how waves bounce, reflect, and absorb for optimal listening experiences. Sound behaves differently in different environments. In air, at room temperature, it travels around 343 meters per second. In water, it speeds up to over 1,400 meters per second. In steel, it can exceed 5,000 meters per second. This explains why a train whistle or tapping a long railway track can be perceived faster through solids than through air. The pitch we hear corresponds to the frequency of vibration. High frequencies create squeaks, low frequencies create rumbles. Volume comes from amplitude, the energy behind the vibration. Beyond music, sound waves have practical applications. Sonar uses sound to map ocean floors and detect submarines. Ultrasound waves provide images of babies in the womb or guide medical diagnostics. Noise pollution in cities affects sleep, concentration, and health, showing that sound is a double-edged sword, both life-enhancing and potentially harmful. Sound waves remind us that invisible energy can convey information, provoke emotions, and even save lives. The air around you is a constantly moving conversation. With waves carrying messages your brain translates instantly, effortlessly, every single second. From the echo of a cave to the hum of your smartphone, sound waves are invisible storytellers shaping our experience of the world. 2. Water waves. Energy in motion. Most people think of waves as water rising and crashing on the shore, but waves are energy, not water itself. Drop a stone into a pond. Ripples radiate outward, but the water mostly moves in circles. The energy travels forward. The medium merely oscillates. This distinction defines waves across physics. Water waves are created primarily by wind transferring energy to the ocean surface. The stronger the wind, the higher and faster the waves. But not all waves originate locally. Swells created by distant storms travel thousands of miles, sometimes arriving at calm beaches as massive breakers. Tides, driven by gravitational pull from the moon and sun, create slow, predictable waves. And tsunamis, generated by undersea earthquakes or landslides, demonstrate that waves can travel across entire oceans, carrying devastating energy. Waves interact with each other and their environment. Constructive interference amplifies wave heights, while destructive interference can cancel them out. Shallow coastal areas amplify waves as their energy is compressed, creating the dramatic curls surfers love. Historical civilizations understood this power. They built ports, lighthouses, and defenses, considering wave behavior. Even today, engineers design breakwaters and coastal barriers using wave physics. Water waves also influence climate and energy. Oceanic waves drive currents, regulate heat distribution, and provide renewable energy through wave power technology. Ships navigate by anticipating wave patterns. The ocean demonstrates that waves are not mere ripples. They are energy carriers, storytellers, and even architects shaping continents over millennia. Water waves show that energy can move across vast distances without carrying the medium. The water oscillates, but the energy travels forward. From ripples in a pond to tsunamis sweeping entire coastlines, waves are the language through which the ocean communicates with the world. 3. Earthquake waves. The pulse of the planet. Deep beneath the Earth's surface, waves propagate through rock and soil, moving energy from seismic events. Earthquakes generate 3 primary types of seismic waves. Primary P waves compress and expand rock in a push-pull motion, traveling fastest. Secondary S waves move material side to side, shaking the ground violently. Surface waves ripple along the crust, often causing the most destruction with rolling, twisting motion. Seismology, the study of these waves, has revealed the hidden structure of our planet. P and S waves behave differently depending on the material they pass through. The fact that S waves do not travel through liquid confirms that part of the Earth's core is molten. Seismographs, first developed in the late 19th century, allow scientists to detect these vibrations and pinpoint epicenters, saving countless lives through early warning systems. Famous earthquakes illustrate the power of seismic waves. The 2011 Tohoku earthquake in Japan generated waves that traveled across the Pacific, causing tsunamis and global attention. Waves can also inform geologists about hidden faults, volcanic activity, and subsurface structures. Buildings are engineered considering local seismic wave behavior, reinforcing the importance of understanding how waves move through matter. Earthquake waves remind us that the planet is not static. The ground beneath us is a dynamic system, pulsing with energy. These waves carry both destruction and information, shaping landscapes and civilizations alike. They are Earth's heartbeat, invisible yet immensely powerful. 4. Electromagnetic waves. Invisible messengers. Electromagnetic waves are vibrations of electric and magnetic fields that can travel through empty space. Unlike sound, they do not require a medium. They form the backbone of modern communication and energy transfer. The electromagnetic spectrum ranges from long radio waves to microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays, with wavelength and frequency determining their behavior. These waves revolutionized human civilization. Radio waves, discovered by Heinrich Hertz in the 1880s, allowed wireless communication, while James Clerk Maxwell's equations mathematically described them. Infrared lets us detect heat. Microwaves cook food. Visible light illuminates our world. Ultraviolet rays can sterilize surfaces. X-rays reveal internal anatomy, and gamma rays track energetic cosmic events. Electromagnetic waves carry both energy and information. Your smartphone, TV, and Wi-Fi router all depend on them. Even sunlight, vital for life, travels 93 million miles through vacuum as electromagnetic radiation. Waves that can pass through the emptiness of space challenge our intuition. Energy does not need matter to move, and information can ride these invisible carriers across vast distances. Applications are everywhere. Astronomy uses gamma rays to observe distant galaxies. Medical imaging uses X-rays and MRIs, and solar energy relies on capturing light waves. Electromagnetic waves demonstrate that the universe communicates continuously, invisibly, and powerfully. 5. Radio and Wi-Fi waves. The digital whisperers. Radio waves and Wi-Fi are invisible messengers that keep our modern world connected. Unlike sound waves, they don't require a medium. A radio tower or Wi-Fi router vibrates electrons, generating electromagnetic waves that carry information across distances. These waves can be encoded with data, turning invisible vibrations into voice, music, or internet packets. Historically, the development of radio was revolutionary. In the late 19th and early 20th centuries, inventors like Heinrich Hertz proved the existence of electromagnetic waves, and Guglielmo Marconi transmitted the first wireless signals across miles of open land and eventually across the Atlantic. Radios became the first way humanity communicated instantly over long distances without wires. Fast forward a century, and Wi-Fi and 5G carry exponentially more data with millimeter precision, enabling live streaming, video calls, cloud computing, and smart devices. The principle behind it is surprisingly simple, yet profound. Information is encoded by altering wave properties, amplitude, frequency, or phase. A Wi-Fi router translates your keyboard and mouse actions into wave patterns that travel invisibly through walls, and your laptop decodes them into commands. 5G uses even higher frequency waves to deliver faster speeds, but its short wavelength means more antennas are needed to blanket an area. Applications extend far beyond entertainment. Emergency communication, satellite navigation, and disaster response all rely on these waves. Even the Internet of Things, smart fridges, thermostats, security cameras depends on waves constantly transmitting and receiving information. Every Wi-Fi signal you send or receive is a tiny vibration racing invisibly through space, carrying your messages, photos, and data without anyone seeing the energy itself. 6. Light and color waves. Seeing the world. Light waves are the narrow slice of the electromagnetic spectrum our eyes perceive. Each color corresponds to a specific wavelength, from red with the longest wavelength to violet with the shortest. Sunlight is a mixture of all visible wavelengths, and the interaction of light with objects dictates what we see. A leaf appears green because it absorbs red and blue light, while while reflecting green. Historically, light captivated thinkers and scientists. Isaac Newton's prism experiments revealed that white light contains a spectrum of colors. Thomas Young's double-slit experiment later demonstrated that light behaves as a wave, creating interference patterns. At the same time, Albert Einstein showed that light behaves as particles, photons, demonstrating wave-particle duality. Light is both continuous and discrete, a messenger that carries energy, information, and color. Applications are all around us. Fiber optics carry internet data at the speed of light. Photography and cinematography manipulate light to capture stories. And astronomy relies on light waves to study stars and galaxies billions of light years away. Even the technology in your smartphone, LED screens, and laser pointers hinges on understanding how light waves travel, bend, and interact with matter. From daily experiences like seeing a sunset to scientific discoveries of distant galaxies, light waves shape perception and knowledge. They allow humans to decode the universe visually, turning invisible oscillations into the vibrant colors and imagery that define our reality. 7. Quantum wave behavior. Matter as energy. At the microscopic level, particles like electrons and atoms act like waves. This is the foundation of quantum mechanics. The famous double-slit experiment shows that electrons, when unobserved, produce interference patterns just like light waves. When observed, they behave like discrete particles. Reality at this scale is a wave of probabilities, not certainties. Historically, scientists like Schrödinger, Heisenberg, and de Broglie discovered that matter has both particle and wave characteristics. Schrödinger's wave equation predicts the behavior of electrons in atoms, determining chemical bonds and material properties. Without quantum wave behavior, modern electronics, semiconductors, lasers, and even MRI machines would be impossible. Quantum waves also challenge our intuition. They suggest that reality is not a static stage, but a dynamic field of energy, where observation collapses possibilities into outcomes. The technology that powers computers, smartphones, and solar panels relies on harnessing wave behaviors at the atomic level, proving that understanding waves is not just academic, it's the key to modern civilization. 8. Thermal infrared waves. Feeling heat. Infrared waves carry energy in the form of heat, emitted by any object above absolute zero. When you feel the warmth of a coffee cup or the sun on your skin, infrared radiation is the invisible conveyor of that energy. William Herschel first discovered infrared in 1800 by observing that temperatures increased beyond the visible spectrum of sunlight. Applications of infrared waves range from night vision cameras to climate science. Military and law enforcement use thermal imaging to detect humans and animals in darkness, while engineers use it to identify heat leaks in buildings. Even wildlife relies on thermal waves. Some snakes sense infrared to locate prey. Infrared waves prove that energy doesn't need to move matter. It can travel invisibly, transferring warmth and information across space. 9. Neural brain waves. The symphony. Inside your head. Brainwaves are electrical oscillations among neurons, coordinating everything from thought to sleep. Scientists first discovered them in the early 20th century using EEGs. They are categorized by frequency: delta for deep sleep, theta for meditation, alpha for relaxation, beta for active focus, and gamma for problem solving and memory. These waves are critical for cognitive processes, emotion regulation, and learning. Disruptions in brainwave patterns can lead to sleep disorders, attention deficits, and neurological conditions. Brain waves also demonstrate how the body communicates internally using wave phenomena, reinforcing that waves are fundamental to life itself. 10. Medical imaging waves. Seeing the unseen. Medical imaging relies on waves to peer inside the human body. Ultrasound uses high-frequency sound waves to visualize internal organs. X-rays use electromagnetic waves to see bones. And MRI uses radio waves and strong magnetic fields to produce detailed tissue images. Without these waves, modern medicine would be blind. They allow non-invasive diagnosis, early detection of diseases, and monitoring of fetal development. Waves in medicine demonstrate the practical power of physics to improve life, showing that understanding waves saves lives daily. 11. Shock waves. The sudden impact. Shock waves are extreme waves generated by explosions or supersonic motion. Unlike regular waves, they create abrupt changes in pressure, capable of shattering objects or causing sonic booms. They are studied in physics, engineering, and aerospace. The understanding of shock waves allows for safer aircraft design, controlled demolitions, and protection from natural disasters. These waves reveal the destructive potential of concentrated energy, reminding us that not all waves are gentle or subtle. Some are violent, forceful, and awe-inspiring. 12. Gravitational waves. Ripples in space-time. Gravitational waves are ripples in the fabric of space-time, predicted by Einstein in 1916 and first detected in 2015 by LIGO. They originate from massive cosmic events, like black hole collisions or neutron star mergers, stretching and squeezing space itself as they propagate. These waves carry information about the most violent and distant events in the universe. By studying them, astronomers gain insights into the cosmos, including the behavior of black holes and the origins of galaxies. Gravitational waves show that waves are not just phenomena in matter or energy. They are part of the universe's very structure, whispering secrets across billions of light years. In summary, waves are everywhere. They carry sound, light, energy, information, and even the essence of matter. From tiny brain waves to cosmic gravitational waves, they shape everything we experience. Every phone call, heartbeat, sunrise, and earthquake is a wave whispering its story. Understanding waves is not just physics, it is understanding how the universe communicates. Once you see the world through waves, everything becomes a symphony of energy in motion. From the ripples in a pond to the colliding black holes billions of light years away, waves are the hidden threads connecting all of existence.